So now you based on your vector, your scalar, and in terms of vectors it is addition, subtraction or multiplication, all this combined. You need to solve a question where you are finding out either the position vector or its magnitude or resultant finally. That is what you are going to study in this particular topic. So here one question I have defined, what is given is a force. Okay, I have already told you a force will be indicated in terms of Newton, that is in normal sense. Okay, which is we have seen previous problems. So under vector it will be shown in terms of vector symbol. It is given as it is 6i, 3j and 2k, and I, j, k are your unit vectors. Okay, basic mathematics. So 6i, 3j and minus 2k acts at a point. This point denotes point P and its coordinates are 1, 3 and 4. Say it's x, y, z, 3 coordinates, and for which you have to determine the moment of this force. A word used called moment. Moment of this force about the point of origin. You are going to determine the moment of this particular force F about a point origin. This should be a fixed point to find out moment. I will tell you what is moment. I will come to the next point. And also we have to find out the magnitude unit vector along it. Right. Now basically, to follow the steps, first we have to write the given force value. I will just say it's an answer. Okay. The given data is first. Say data. I say given data. Okay. It says F is given as 6i minus 3j minus 2k, and one more point given P, which has got coordinates of 1, 3, 4. Basically you need to write a graph and indicate this force value as well as this point, because please remember I have told you any body which is at space, in space I can say, we are defining at which position it is first basically, because from the floor or from the left hand side or from right hand side or from the top, we will have to first say that where is that point is, and that point is at some place which will have some distance from x axis, y and z axis. That's normal. That first we have to indicate in terms of a graph. Then we are going to next step to find out the position vector. Position vector is nothing but again the position of x, y, z from the origin point. Then you are finding out using your any of the products, your that addition, subtraction, whatever it is, finding out the answer. And here it is asked its moment. So before going to this, what is your moment is, I will just take and draw a graph for this. So I will just write this is your x axis, y and z. Okay. So this point I will take it as your point P. This is indicated by terms of 0.134. So if this point P is at a distance of 1, 3, 4 from the origin point. So from here I will write this origin point O, and this goes like this. This is my distance. What I mean to say, I have already showed in the previous graph that this becomes my R, my position vector. This is my R, this is my distance, and this 1, 3, 4 denotes my x value, y value and z value from the origin point. I can say x is this distance, y is from y it is the height, z is from this 4, perpendicular, right? And here actually the force starts moving, and that force value is from this point only the force is acting. That force value is this. What is that? 6i, 3j and 2k. Again, right, this F is F vector 6i minus 3j and minus 2k. This is the first step you have to indicate by graph, compulsory, right? And coming to the next step, I'll just make it a difference because you need not get confused. So after that, what did you see? First I am writing position vector. Position vector is my indicated symbol R. How will I write? See, the position point P has got 3 coordinates x, y, z. This is nothing but your ijk. Means your ijk is a value of unit vector value 1, I is equal to 1, j is equal to 1, k is equal to 1. And this indicates what is that value of I is 1. And j shows it's 3j and k is 4k. That we are writing in terms of vector distance. So I write I is as it is I because the value of its value is 1 and 3 is plus j is 3j plus k is 4k. So vectors again. This becomes your position vector. As well as next you have your force value. Now your question is you have to find out the moment. Now I come to what is meant by a moment is. Moment means it is not movement, it is moment. Moment is nothing but the applied force will be 1 point and that force will be applied in one direction to that direction and you will have a common origin point wherever it is. From the origin point, the perpendicular distance to that particular point is a height, some distance it is. Say suppose I am applying a force from this area, okay, when my body is like this is my point. Consider this to be my origin point. From origin point I will consider this value as say suppose some 2 centimeters or 10 centimeters. I am applying force in this direction, right? My force value is 5 Newton. This 5 Newton into this 5 Newton applied into this is my perpendicular line, right? This force is in this line, so opposite is my perpendicular line. This perpendicular line, my applied force into perpendicular distance from the base origin. That becomes moment. When I write in terms of vector, I will write moment is, I will just write a definition. Moment means the force into perpendicular distance. Perpendicular distance. Is it okay? So in general if I write force as symbol F and I will write it is perpendicular distance of any value. Okay, say for example my distance I denote by value x. I will write x it is. Why I am writing symbol perpendicular is you have to remember force into perpendicular distance is equal to moment. For example, if my origin point is O here, I will write my symbol is moment is m in an m vector here and my f I denote my f from in my vector point is O, f into what is the perpendicular distance here? Wherever it is I have to denote with the terms of this baseline, my x line, or if I go to perpendicularity for y in another area, z in that plane. So I will write from the baseline I have a distance of r distance is my max, because this from this point I indicate this is the direction, this becomes my distance. From this point it will be at this distance, from y in this direction, from z direction is in this area. So my force into perpendicular distance is, here I show it as r, because r is my position vector. What is the position from origin is the question. It is r, and I consider to be a perpendicular distance. In general, moment means force into perpendicular distance. I will take, before going to this, I will take another example. For example, I have a small rod, okay, a rectangular rod. This rod is kept in a horizontal floor, a flat surface. I am applying a force of 2 Newton here, right? And the total height of this rod is, say suppose 3 meters from the ground, because anything you need to keep in a base ground will have a equilibrium, stability. So here if I take moment is equal to again force into perpendicular distance. See, I am repeatedly writing perpendicular symbol because you have to understand moment means the applied force into the perpendicular distance wherever it is. The perpendicularity can be like this. Even if I draw a rod like this, If my apply force is like this, it becomes perpendicular line. It just to show this perpendicularity. That's it. Clear? So perpendicular, this is it. Now, applied force is 2 Newton. The total height of this rod is 3 meter. I am considering from this point origin O, because the base, I can simply write my moment is nothing but applied force value is 2 Newton. Don't write Newton here. Into, what is my distance here? From any fixed point only, I have to consider the distance. I cannot take a point as I wish, or depending on the problem from different distance, because we need to fix a baseline from where any point we define have a distance. For example, in this rod itself, at the distance of 1 meter, I need to find out a moment. I should take 1 meter only, because from the baseline it is 1 meter. At 0.75 meter, I go for 5.7 meter. Very simple. So, say suppose consideration at the third meter, height of 3 meters, my force is 2 Newton. I am writing the moment is, definition says force is equal to, moment is equal to force into perpendicular distance. What is force applied? 2 Newton. What is the distance from the base? That is perpendicular distance. See, this is a line. This line comes and this is the distance. Applied force is here. This is my distance. So, just take perpendicularity. Wherever it is, you can turn it, or depending on the direction of the force applied. Okay. So, what is distance here? 3 meters. 2 into 3. It becomes 6. And moment, unit of moment, simple it is, force is Newton and distance is meters or centimeter, millimeter, whatever it is. So, I will write 6 Newton meter. Moment, unit of moment is Newton meter, because it is definition is moment is equal to force into perpendicular distance. So, your force into perpendicular distance is in terms of meter or millimeter or centimeter, you can write Newton centimeter, Newton millimeter, all it's correct. Right? So, normally you convert everything in terms of meter and write the value. So, this is how we write in normal conditions. Right? And in vector it is same, under vector also it is the same, but only difference is you are writing in terms of this vector symbol. Okay. And this one, now it takes a cross product, multiplication. Your basic mathematics again. But this I cannot simply multiply, because you have 3 points here and 3 points here. This force has got I 6 value, J is 3 and K. Now I will go for this cross product. What is normally cross product is, I will just find out a modulus. In the sense, I will go for moment. I will go for I, your J and K. Then I will write the values of my position vector first. But how much is this? 1, 3, 4. Is that okay? And then last one, what I have? Here 6, minus 3, minus 2. This is the value of 1, 3, 4 for your position vector. 1, 3, 4, x by z. And ijk is your unit vector, it is always applied. And this 6 minus 3, 2 is, minus 2 is for the force value given. You are finding out the answer here. You will get an answer. Say for example, I am not calculating it, but still if you want to calculate, you can just, it's normal matrix. That's all. You get a value. Say if I get some 6i or plus some 3j, I'm not writing the correct answer, I'm just giving an example, plus 4k, whatever it is. This answer is your moment value. Okay. And first step, you find out, determine the moment of this force about the point of origin. Now I determine the moment of this force. This is my first step. Second step, I will just clear this part. So I will go, kindly remember, after this, after finding moment, I am coming for next one. It says find the magnitude and unit vector along it. Magnitude is the one, it is the value. I already told you, magnitude means it is the value of force. How much it is? 1 Newton, 5 Newton, 100 Newton, 1000 Newtons. That we have to find a value. So here, what I have a moment is here. Now what will I do? This magnitude I can find out by taking the root, square root of this value. 6i whole square 2j whole square plus 4k whole square. Again I repeat, I am not writing the correct answer here. The matrix you need to solve it and write the exact values. That you will do it, because normal matrix, mathematics is matrix or modulus, whatever it is. So this, suppose I get some 40, whatever the value is. When you square it, what will happen? I square 1, j square again 1, k square. That you know. So you will get a value of this one. So this becomes your magnitude. Magnitude is nothing but the answer from your moment that you are just taking a square. See, these theories I have not explained, because if you go to the problem, you understand what we are doing. That much is very much enough. There are a lot of theories given in the book. It is fine, you will very well understand, because basic mathematics it is. In the problem, you need to understand what you mean by position vector. How do we correlate that, either in terms of the cross product, addition, subtraction, whatever it is, and what do we need to find out for magnitude and unit vector. And unit vector, now your magnitude is solved with this value. This is a value which is for a force. This I cannot write ijk, because it is total value of force. It's in terms of the Newton. So now next I will write it as unit vector. How to find unit vector? Unit vector in terms of ijk it is. Now I will write this 40 is the value, okay, and the value what I find out is 6i, 2j and 4k. This I have to individually divide 6 by 40, say suppose plus or minus 2j by 40 plus 4k by 40. This becomes my unit vector. After finding this value, again the force value whatever given, that we are dividing by this value. This becomes unit vector. And again I go unit vector in the sense your ijk, in terms of ijk, what is this? The requirement. So what you are finding is, first you are finding the moment, then magnitude and unit vector. This procedure you can apply for any problem to get the answer. And ultimate aim of this is to see the what is the resultant value, with which now I can, the purpose of this problem is what? The magnitude of this force is 40 Newton. That is my meaning. In what direction it travels? It travels in the direction of this. Any angle you can take it out. And 134 is the point. What is the moment value? Moment is force in perpendicular distance. Force applied is this one. Those values 6i, 3j, 2k. Now its total weight is 40 Newton, I can say, value. And the direction is this direction. That is the meaning. So anything you find out moment, kindly don't forget force into perpendicular distance. Perpendicular distance here it's shown in terms of position vector. And in normal condition I have defined any force applied to perpendicular distance. If the force is in this direction, this will be your distance. That's it. And you need to have set to have a basic point or the origin point to measure the distance. That you multiply it with the applied force. That's it. Right? Now the continues in the previous problem that we have seen the moment. So we have already explained that it is force into your perpendicular distance. This step is an advanced step compared when considering to the problems which I have just written on the board now. This moment, your force into distance or a position vector, all this is based on which the body is in space and the force and the point where it is from x, y and z directions. Right? Now the question given here, it is just to find out, there is a vector called A, which is, it says it's 2i plus 4j minus 7k, and a vector called B, 3i minus 5j plus 6k. For these two vectors you will have to find A plus B, that is, it is addition, A minus B subtraction, A dot B it is dot product, A cross B it is cross product. So all these values you have to find out the answer, because again you are finding out the resultant R. The purpose of this is to find out the resultant value R so as to keep the body in equilibrium. That is the purpose. And the second question, if you see that if the position vectors, again the word position vector, I'll write the symbol R, of 2 points A and B are 3i minus 5j plus 7k and 6i plus 3j minus 5k, then find A B vector. It is not given either it is dot or cross. We'll have to know what is this. So let me go to the first one. So what is this? These two vectors given. How do we find out A vector plus B vector? Just simply it's addition. You can just add this and write it is 5i, it is 4 minus 5, it is minus 1 minus j, okay, and it is minus 7 and plus 6. It's again minus 1 k, that is minus k. So it is just an addition, then you go for subtraction, then it is multiplication and cross product. So as it is, it will finish this problem, and the last one it's a cross product. What will you do? Go for modulus. How do you write this? You write ijk, the unit vectors, the values of vector A 2i, it's 4j minus 7k, and B it is 3 minus 5 and 6. This you have to find out the modulus value. I'll guess say suppose the example of some vector values of in terms of I plus j, suppose k. So this will end up easily because it's basic mathematics, wherein you are just finding out addition, subtraction as well as cross or dot products. But the second question, it is just given if the position vectors, the starting itself it denotes the position vectors are of 2 points A and B as the value given here. We have to find out AB vector. Now for this what we are doing is you need to draw a graph. The previous one it is basic mathematics again, you need not go for a graph, and this question is totally carries maximum of 4 marks I can say in terms of you have marked the value, which is a normal mathematics. This is the one which you have to test that based on position vector you are finding the answer. This position vector is again R, your value, and in terms of two values of A and B it is given 2 points. How to denote this? You are drawing a graph again. X is this is Y and this is Z. I need to indicate or show 2 points here. One point with the value of, that is one point called A, the value of 3i minus 5j plus 7k, other point B with the value of 6i plus 3j minus 5k. How will I denote? I take 2 points from this origin O, one point is A and the other point is B. What I am trying to explain is these 2 points take a position from an origin only. I have already indicated that any point in space, to find out its resultant value, you need to set a basic line or a datum line from the origin, from the ground, which is known as origin O here. From this point O, any plane you consider x, y, yz or zx, we are worried about the distance from x, from y and z. And here there are 2 points given. The position vectors of 2 points, point A and point B are given. I have just drawn this graph and I make this point A and B in the same level, but its position vectors are different depending on the value. You can check this value. This position vector A has got 3i minus 5j plus 7k. This 3 is x, minus 5 is y and 7 is z. And when you go for position vector of B, 6, 3 and minus 5k. Now what to do here? I will write it is A vector given as 3i minus 5j plus 7k, and B vector is given as 6i plus 3j minus 5k. This is the value given, and these values, it shows the positions of A and B. But I can say when you take this graph from the origin, if you check the distances of this point O to B and O to A from the base point O to A, I will say this is OB and this is OA. Which is the higher one here? This OA and OB are two values, two distances. OB is the higher one and OA is the lesser one. Now we have to find out just AB vector itself. You can use any law, addition law, subtraction law, or cross product, dot product, whatever it is. You have to find out the value of AB. And it is very simple. It shows that the position of B is farther, or it is distance, more distance from point A, and A is less. So if I take the length of OB and OA, I can simply reduce. I will say OB minus OA will give some value for me, right? And this is nothing but your subtraction law. From the law of subtraction. From the law of subtraction. This formula is nothing but from the law of subtraction. I am reducing the distances of OB minus OA. That's it. My point is A and B is given here. OA, I'll just take this my OB and OA. From position O, A is at a distance of R. From position O, B is a distance of another R. Position vectors. But when you take the x-axis value, OB is a bigger one, OA is smaller one. I'm just reducing the value. Now what to do? You just take OB here. OB is this 6i, 3j, 5k. 6 and OA is 3i minus 5j plus 7k. Reduce these values. It is immaterial of which is more and which is less. Because from the graph you can see this OB length is higher one, OA is smaller one. The bigger minus smaller. Good answer. So this is just 6i minus this 3i. It is minus 3j and minus 5 plus 3j minus 5j it will be minus of 2j because it is higher. Again it is minus 5 plus 7. So it's again minus 5 minus of it is 7 it is. You are reducing it. There's OB minus OA. You have to add it up. Minus 5 and minus 7 is minus 12. Okay. You right? So this value, whatever the value may be, you can check with your calculations. But the purpose what I have to say is, by the graph you have to indicate the value of which is the higher one. Higher one in the sense, from the x-axis or from the origin, I can denote that OB is got a value of a bigger value compared to OA. So this problem compared to the first one, or which we solved before, this it just indicates the position vectors from point A and B, but we have to find this AB vector. Usually you get a questions either from the first problem which I solved before in terms of position vector, finding magnitude or its unit vector, or like this, because this is based on just 2 marks questions. It's just a normal your addition subtraction of based on your +1 or +2 mathematics. It's not given much importance in the either university exams or the normal test. You better have to read about these position vector problems, or it depends on your magnitude as well as finding out unit vectors. That's very, very important. Please concentrate on these type of problems wherein you are finding out the resultant value, but the drawing of the graph is very, very important, because every graph it denotes the space, or in space what is the position taken by one point, and where is your position vector from origin. That's very important.